Hello, in this video I'm going to be talking about something known as stylometry. Stylometry is the idea that we can learn something about the relationship among a bunch of different texts based on how they use words at different frequencies. Now, the techniques I'm going to be talking about are applicable to texts in any language, but I'll be focusing on texts that were originally written in Chinese to think about how genres relate to each other stylistically. So I'll be dealing with how to visualize textual relationships by comparing the relative frequency of terms, specifically Chinese characters, using something called principal component analysis, or PCA. PCA is essentially a linear algebraic technique that will allow us to see the variance within the dataset. It will allow us to take a dataset that is highly dimensional, that is looking at hundreds or thousands of different characters at the same time, and reducing it into 2 dimensions so we can visualize it on a screen. So let's imagine that we have a text, and we want to compare it with 5 other texts. Let's say in these hypothetical texts that we have decided that the words and of will tell us something about their relationship. So text 1 has and 6 times and of 7 times. Text 2 has and 10 times and of 14 times. Text 3 has and 8 times and of 3 times, and so on and so forth. We can rearrange these texts into a matrix with and of as 2 columns. Let's look just at and first. We can organize these texts based on how often they use the word and, just on a simple number line. We can do the same with the frequencies of occurrence of. Now similarly, we can plot this in 2 dimensions. We can compare the use of the term and the use of the term of, and learn which documents are most similar to each other. But let's imagine that instead of just and of, we have more words we're interested in looking at. Let's say the also will tell us something interesting about this. Well, 3 dimensions is still easy for us to visualize, but 4 dimensions, we can mathematically calculate the relationships among these documents, but we can't visualize them anymore. And often we'll want to look at many more dimensions than that. 5 with he, 6 with she. Sometimes as many as 1,000, 2,000, 10,000 different words will tell us a lot about the relationships among documents. So instead of plotting these texts on one axis that is and the other that's of, we'll plot them along principal components. Now each principal component will tell us something about the variance within the dataset. That is, how do different words occur at different rates in all of these documents? The first principal component, which will be our x-axis, will show us the most amount of variance within this data set. And you can think of this as rearranging the data to get the best view of it. Now the y-axis is the second principal component, which is the second most amount of variance within the data set. Now because I'm working with Chinese texts, and I'm interested in genre, I'm going to label my texts based on genre. So the figure you're about to see will have texts of 3 different genres. The dots that are in blue are all chapters from official historical texts. These are texts that were officially vetted by the imperial government and talk about historical events that the government thought were important. In magenta, we have historical romances. These are chapters from texts that were fictional but talked about specifically historical events. And then in green, we have chapters from novels. These are purely fictional texts that sometimes touch on history, but are largely focused on things that have no historical basis. What I've done is I've looked at about 500 different texts, or 7,000 or so chapters from all of these texts. And when I compare the frequency of use of the 1,000 most common terms in these documents, I get a figure that looks like this. We can see that official histories, shown here in blue, dominate the left side of this graph. But they're also fairly dispersed across the y-axis. Fiction, on the other hand, are most densely concentrated on the right side of the graph and show less dispersion along the y-axis. Historical romances in magenta dominate the middle, and they actually bridge the gap between the earlier 2 genres. Now, to be able to properly interpret what's happening here, we actually have to look at the specific words that are being used in different ways. And in this case, it's Chinese characters. And we can do this by looking at the component loadings. The further away given character is from the sender, the more influence it is exerting on texts that appear in that direction. So in the bottom left-hand corner, by itself, you have the character zhi. This character means that texts that show up in the bottom left-hand corner of this particular graph use this character at a relatively higher frequency than those that show up at the top left, which in turn use the character de and le at a higher rate. What we can do is we can use this as a way of trying to interpret what these axes mean. They're abstracted axes, but by looking at these loadings, we can kind of see what's going on. I'm going to spread these out to make it a little easier to interpret, but what we can see is that on the left side of this first principal component, we have characters that are much more closely associated with classical Chinese language. And on the right, we have characters that are more associated with vernacular Chinese. Now, this is a general trend rather than true for all of these characters, but it is a useful way of interpreting this first principal component. Now, if we look at the second principal component, seen here spread out again, what we can see is the top of the y-axis is heavily dominated by numbers and geographic locations. What this means is that the histories are spread out based on how often they mention numbers and places, perhaps not a surprising thing. Whereas the fiction tend not to be as dispersed as the histories. So, when we look at the original plot again, now we have a way of interpreting it. We can see that the novels tend to use more pronouns, be a little bit more vernacular, whereas the official histories, some of them very heavily focus on geographical spaces in ways that the fictional works don't. We can actually compress this and look just at a single dimension at one time. And here we're looking at the first principal component, and I'm going to break these apart so we can more easily see how they're dispersed. What we can see, and I'm going to show you some histograms of where they appear along this first principal component, and the characters themselves for reference, what we can see is that the histories are far more dominant on the left side of the graph. The historical romances are pretty evenly dispersed across the entire principal component space, and the novels are focused largely on the right side. If we look just at the second principal component, what we can see is something that's a little bit different. We can see that now it's the official histories that in fact are much more widely dispersed. And here you can see in this histogram that the histories appear fairly far up and down this y-axis. The historical romances are concentrated more towards the bottom, and the novels are also concentrated towards the bottom. So we can use this kind of analysis to really start to plumb the relationships among these documents at the corpus level. But now the question is, how do we get from actual real language documents to a plot like this? Well, we're looking at different frequencies of terms, so how do we do that? Well, let's take the case of the novel The Plum and the Golden Vase. Here we can see all 100 chapters of this. There are some interesting things happening here, but that's outside the scope of this particular animation. Let's look just at the first chapter of The Plum and the Golden Vase. What we can see is, in its plain text form, it looks something like this. The first chapter tells us about Wu Song beating a tiger up in the mountains. But to go from this to a representation that we can study using linear algebra, we have to take a few steps. The first step is vectorization. Essentially what we want to do is we want to take that plain text document and turn it into something that we can represent in space. In order to do this, I want to create a bag of words vector representation. Essentially, I just want to count up how often every character in this particular chapter occurs. You can see here, we see Di once, Yi once, Hui once, and so on and so forth. And what we'll do is we'll keep track of how often every character occurs and how long every chapter is. You can see as we move forward that it's doing precisely this. When we get to Fu, we'll see the first character that occurs twice. So it's counting these characters. And so we do this, but in practice, it's a very, very quick operation where each chapter might only take a millisecond or so to be calculated. Once we've counted up all of these words, what we see is that the character zhi occurs 35 times, bu 164, and so on and so forth. And we do this for every chapter in this particular novel and every other chapter in all the other texts we're interested in working with. So now what we have is a bag of words vector space representation of these texts. And this is called a bag of words representation because it doesn't take context into account. There are other ways of doing that, but in the context of this, it's not really necessary. So now we actually have to take into consideration how long each chapter is. Because you'll notice that chapter 1 is over 11,000 characters long, whereas chapter 2 is only about 6,400 characters long. So if there are big disparities in the length of the documents that we work with, this will influence the apparent relationships among them. So what we do to take account for that is we divide the occurrence of each character by the length of the chapter it's found in. This is in effect a way of normalizing it. This will give us a character frequency. But we can also multiply this by 1,000 to see how often does this character occur per 1,000 characters. Then in turn we'll use this number to represent the character instead of that original raw count. Now there are other ways of normalizing, but this is a relatively effective way of doing it. And we do this for every character in the text. Essentially, we're now representing our corpus as a matrix, and each chapter is a dot in n-dimensional space, where n is the number of different characters we're looking at. You can think of this as an m by n matrix, where m is the number of documents in the corpus, here the number of total chapters across all of the text we're looking at, and n is the number of columns or unique characters we're looking at in the data set. Now, in practice, we'll often limit the number of terms, because often certain terms tell us more information about certain things. So if you're interested in authorship, often the most frequent terms are the most useful. If you're interested in genre, sometimes more characters are useful, sometimes fewer characters are useful, and sometimes it's effective to establish a specific vocabulary, to look at specific characters that will tell us something about our works. Now often, in the case of Chinese, we completely ignore white space and punctuation because the original text didn't have these things in them. When we have this matrix, what we can do is we can actually reduce its dimensionality using principal component analysis to see how do these texts relate to each other based on all of these different variables that we have that we're working with. Essentially, we feed all of this data into a linear transformation, and then it will return to us new locations along these abstracted axes that we can use to visualize these relationships. Here you can see that these 6 chapters show up in these places in this principal component space. We can see that, yes, this is indeed from The Plum and the Golden Vase, and that this is part of our larger data set. And this is essentially how we can use principal component analysis to study the relationships among documents based on how they use terms in different ways. So thank you for taking the time to listen to this, and I hope that it was useful. If you have any comments or questions, please feel free to get in touch with me. Thank you.